11.4 compound events. I can find the probability of compound events.
Yay, Avery! Good job. Finally, we had a smart person introduce the video. Just kidding. All right, guys. Everything we did here today is big time. Space, sample space. Everybody, iPads down, by the way. iPads down. I want eyes up here. True or false? A sample space lists almost all possible events.
True. False.
Sample space lists all possible events, not almost all of them. Pay attention. Tree diagram shows the entire sample space. We'll show you that in a bit. And then the fundamental counting principle has a bit of a formula. M times N. Remember what M stood for?
Yeah.
What's M stand for?
Possibilities.
What does N stand for?
Possibilities.
More possibilities. It's just a different set of them, right?
Yeah.
Okay, so M stands for the first set of possibilities, N stands for the second set of possibilities. What if we had another set of possibilities? Would we just multiply that as well?
Yes.
Yeah. So the fundamental counting principle says if you have compound events and you want to know how many possible outcomes there are, you just multiply the total outcomes of the one event times the total outcomes of the second event times the total outcomes of the third event, and so on and so forth. And then obviously compound means what, everybody?
More than one.
Number 5. I just said number 5. Everyone read that to yourself real quick. Number 6. How many outcomes are possible if a quarter is flipped 3 times? Well, if you flip a quarter 3 times, on the first flip, how many outcomes are there?
2.
On the second flip, how many outcomes are there?
2.
On the third flip, how many outcomes are there?
2.
So what is 2 times 2 times 2?
8.
Okay, so if I asked you to prove it, you would do this. On the first flip, so let's call this our first flip, you could get a head or you could get a tail, right?
Yes.
Okay, on our second flip, you could get a head or you could get a tail. The thing of it is, though, if you got a head in the first flip, you have to realize that the head or the tail could go with the first flip, or if you got a tail in the first flip, your second flip could go with the tail. Yes or no?
Yes.
And on the third flip, what are your possible outcomes? Head or tail. But again, you need to take into consideration your other 2 flips before that. So if you count all of them up, we listed them all out. Those are the 8 different outcomes. What do we call this again? What is a list or naming all of the outcomes called?
Sample space.
Sample space. Does the fundamental counting principle match up with our tree diagram?
Yes.
Number 7 is spinning a spinner. Again, we did the fundamental counting principle. We spun the spinner twice, and then we showed you all the possible outcomes in the tree diagram. I don't think we need to talk about it. And then Zofia decided to open a restaurant. And here were her choices at the restaurant for you to eat when you went to see her. She offered these appetizers, these 3 main dishes, and these desserts. If she offered 2 appetizers, 3 main dishes, and 2 desserts, how many combinations are there, you guys?
12.
2 times 3 times 2 is?
12.
Beautiful. What, though, are they all is the question. And so what we did is we made a
Tree diagram.
and we listed all 12 of them. Now some of you might say, well, Mr. Ponder, why would you want to list all 12 of them? And your answer is? Because if I asked you what is the probability someone will come into Zofia's restaurant and order fish, you could actually look at your tree diagram and determine how many different times someone would order fish in her 12 meals, right?
Yeah.
If someone came to a restaurant and wanted to order fish or ice cream, could we figure that out?
Yes.
Is this the key word here?
Yes.
Because look at letter C. If someone came to a restaurant and I'm sorry, this was pasta or ice cream. If someone came to a restaurant and wanted to order pasta and ice cream, would that change things?
Yes.
Because does or and make a big difference?
Yes.
Totally big difference. Questions?